So for 37, they want us to use a computer algebra system to find the volume when we revolve the area between these two curves about the line y is equal to -1. So basically, all we have to do is set up the integral, and then the computer will do all the rest for us. So the area between these curves, and I've gone ahead and I've input these in a graphing calculator. That's my curve sine squared of x and the x-axis. So it is this area, and it tells us to consider between 0 to pi, right? So we already know that our integral goes from 0 to pi. And now it's asking us to revolve it about the line y is equal to -1. So about this line, right? And let's think about what happens when we revolve it. Well, to begin with, we're going to get this washer where the smallest part, it touches the x-axis, and it goes like this. And then the biggest part, it touches the curve sine squared is equal to x, and it goes like that. And basically we're summing these up from 0 all the way up to pi, right? We're going to end up having a bunch of these disks that go like so. And when we sum up all of them across the x-axis, we're going to end up with a volume. Now, our volume is going to kind of look like this horizontal cylinder with a hole drilled through it. So we just have to figure out how to calculate these disks, right? So our disks are going to look like this. They are going to look like a bigger circle, from which I'm going to remove the smaller circle in blue, so that I can just get this this ring in orange, right? Which is kind of which is what we do have here. Maybe I should have drawn it in a different color, but you guys see what I mean, right? That's going to be like this. Yeah. So basically, when we revolve it, this is going to be this ring is going to be described by a1 minus a2, where let's see, a1 is this circle that has the biggest radius r1, and a2 is the smaller circle that has the radius r2. So basically we have to take the area of the bigger circle and then remove from it the area of the smaller circle to get a1 minus a2, and then sum up that whole thing from 0 to pi. So let's talk about a1. How do we calculate a1? Well, a1, the biggest circle, it has a radius that goes from here to the center at y is equal to -1, all the way up to where it hits the curve, right? So it changes, this height changes. If we were here, it would go 1, and then it would hit the value of the curve. So basically, to get this height, we have to travel a distance of 1, that is a fixed distance of 1 all throughout. And then from that distance of 1, we climb the distance of the function, the height of the function, right? And this is where that height is always changing. And maybe I'm going to I have too many drawings out here. Let me simplify what I'm doing. Okay, so if I have to go from the center all the way out to 1, that is fixed, that doesn't change. And then, from -1 to 0, and then from 0, I have to go up the height of my curve. And the height is just the value of as sine squared of x. So that value is going to go 0 to sine squared of x, and then we add in a little 1 at the bottom to do it. And if we do that, that's going to give us the radius of our biggest circle here. So once you do that, we can see that a1 is given to us by pi times 1 plus that value, that sine squared x squared, because our area here is just pi r squared. So we have a1, which is equal to, let's expand that, that's pi times, that's 1 plus 2 sine squared x plus sine to the 4th power of x. That's our a1. And now let's think, what's a2? Oops, that is not what I meant to do. A2 is basically going to be the smallest circle, right? And it's interesting because a2 is fixed. The radius is always going to be the same. It's always going to go from here all the way out to the x-axis, right? That does not change no matter where I'm going. So thankfully, this is a very easy circle to calculate. It's just basically pi r squared, where the radius is just the distance from y is equal to -1 to the x-axis. That's a fixed distance of 1. So pi times 1 squared. So when we're doing a1 minus a2, which is going to give us that ring as we talked about, right? Which is what we want. That is pi. So a1 is 1, 1 plus 2 sine squared x plus sine fourth of x, and then minus 1, right? So these are going to cancel out. Therefore, our integral is just going to be pi times the 1s, they cancel out, they go to 0, so it's just 2 sine squared x plus sine to the fourth of x dx. So now it's telling us to use a computer algebra system. So I'm using Symbolab, which is Symbolab. But you guys can use any other online calculator that can integrate. So I'm just going to put in the integral from 0 to pi of 2 sine squared of x plus, that is plus sine to the fourth power of x dx. So let me sum this up to find the definite integral. That's going to give us the volume, right? And let's see where it gets us. It's doing the calculation, and it gives us this volume. It gives us 11 over 8 pi squared. That's the volume that we get. So basically all we have to do is just set up this integral and then let the computer do the work for us.